Good evening, my dear children. I welcome you all to my class, and this is Suma, waiting to celebrate and enjoy mathematics with you all. So in the previous class, we were discussing with the relation. We just got to know what is a relation, what are the types of relation, what is an equivalent set or equivalent relation. So if we want to call it as an equivalent relation, obviously we need to have three conditions satisfied. What is that? Reflexive. I just gave you an example of when I am standing in front of a mirror, you will be getting your image itself. So that is reflexive. And next one is symmetric. What is symmetric? From here, from your college to your house and from your house to college, that is A comma B, B comma A is symmetric. And the last one is the transitive. Transitive, it's something like A comma B and B comma C belongs to R, which must imply A comma C belongs to R. I had actually given you an example of a thing which the student will ask his lecturer in the previous class. Fine. So today we shall just discuss a few of the problems on this, where for the NCERT students you will be getting this for 3 marks. What is that? A set is defined. A relation on a set A 1, 2, 3, 4 till 14. A relation is defined as R is equal to x comma y, that is 3x minus y is equal to 0 for all x comma y belongs to the main set A. This is very important, which they normally keep asking for 3 marks. How do you answer this question when such question is actually asked in an examination? So first, the thing that you are supposed to write is, you have to write the given content. This is the given statement. What is the given statement? They have given you a set A and they have given you what is the relation R is equal to x comma y, 3x minus y. I have to write R here. What is R? With only this, it is very difficult for me to understand this. So what do? I'll just go by taking x and y. So this can be written as y is equal to 3x. Fine. This can be written as y is equal to 3x. Now, excuse me. Now, when x is equal to 1, I am just picking the values of x from where? From the set here. When x is equal to 1, what is the value of y? It is 3. When x is equal to 2, what is the value of y? It is 6. When x is equal to 3, what is the value of y? 3 3s are 9. When x is equal to 4, what is the value of y? 4 3s are 12. Can we take 5 here? When I take x is equal to 5, 5 3s are 15. But till where do we have the set here? We have till 14. So 15 is beyond that. We are not given any permission to cross that. That is why I will not be taking x is equal to 5 here. I will stop only till x is equal to 4. So now can I write the relation? I had actually told you like it is a Cartesian subset of a Cartesian product. Cartesian product is what? The set of all ordered pairs, that is x comma y. It is of the form x comma y or a comma b. So now this is nothing but this can be written as x comma y. It is 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12. This is what I have a relation. Now the question is asked, check whether it satisfies reflexive, symmetric and transitive. So now for it, I have to go for checking the reflexive. What does the reflexive say? As x comma x belongs to R, immediately you should write from where is this x coming from? For all x belongs to the main set, it is actually coming from, we are picking the elements from the main set A. X belongs to A. Will this condition be seen here? Will you be able to, what is x comma x? If I just take the value of x is equal to 1, 1 comma 1. Do we have 1 comma 1 here? No. If I just take the value of x is equal to 2, I need to have 2 comma 2, because when you are standing in front of the mirror, you will get, you will be able to see your image itself. So it is 2 comma 2. Do we have 2 comma 2 here? Do we have 3 comma 3, something like that? No. So can I just say x comma x belongs to R here? It's impossible. So now this is not reflexive. Since x comma x, we are not able to find out any 1 comma 1, 2 comma 2, 3 comma 3 in this relation. So this can clearly say that R is not reflexive. If you write only this will not complete the sentence. R is not reflexive. On what set? On set A. R is not reflexive on A. Now this is reflexive. Now the second thing is symmetric. You can just even give an example. What is that example? Since 1 comma 1 does not belong to R, R is not reflexive. You can even quote an example for this. Now the next thing is symmetric. What is meant by a symmetric here? I had told you, like as A comma B belongs to R implies B comma A belongs to R. Let's see whether this implication works or not. If I just take A is equal to 1 and B is equal to 2. Or you can even observe the thing here, because we will just pick out the elements from this. So if I just consider 1 comma 3, I need to have what? 3 comma 1. Do you have anything like 3 comma 1 here? No. If I just take 2 comma 6, I need to have what? 6 comma 2. Do we have any 6 comma 2 here? No. If I just take 3 comma 9, I need to have 9 comma 3 here. Do we have any 9 comma 3? No. 4 comma 12. Do we have any 12 comma 4 here? No. So can we apply this now? It's impossible. As A comma B belongs to R. Okay, fine. 1 comma 3, I am saying that it belongs to R. But do you find any 3 comma 1? It is not seen. So that is why I can just say that A comma B belongs to R does not imply B comma A belongs to R. That is example 1 comma 3, right? 1 comma 3 belongs to R does not imply 3 comma 1 belongs to R. If this condition is not satisfied, can we say that it's symmetric? No, it is not symmetric. Hence, reflexive is also not satisfied and even symmetric condition is also not satisfied in this. Let's see with the transitive. What does the transitive say? What is the definition of a transitive? As x comma y belongs to R and y comma z, always in transitive, remember, you will have 3 elements x, y and z belongs to R. You need to say, you need to go with and here. X comma y belongs to R and y comma z belongs to R must imply, if it has to be a transitive, it must imply x comma z belongs to R. By looking at this relation, can we see whether it is a transitive? So now I'll just go with, see, look at this, the end elements must be the same. I'll just take an example of 1 comma 3. Do you have any set here, any element which starts from 3? Yes. I'll just compare these 3. 1 comma 3, 3 comma 9. So the resultant must be 1 comma 9. Do you have anything here 1 comma 9? You don't have. 1 comma 3, 3 comma 9, that is x comma y and y comma z. I have 1 comma 3, 3 comma 9. The resultant must be 1 comma 9, that is x comma z. But we don't have 1 comma 9 here. So can we call this as a transitive relation? No. So can we say it implies? No, it does not imply here. Example, from the same set, 1 comma 3 belongs to R. I accept this. Okay, it is very much there in the relation. And now 3 comma 9 also belongs to R. Yes, 3 comma 9 is also there in this relation. Fine. I should have 1 comma 9. I should have 1 comma 9. Do we have 1 comma 9 here? No, it does not belong to R, which implies that 1 comma 9 does not belong to R. Either you have to go with this imply, not implies, or this. Don't go with two simultaneously. So here 1 comma 3, 3 comma 9. So you need to have 1 comma 9. 1 comma 9 does not belong to R. So it clearly says that it is not a transitive relation. So now reflexive is not satisfied, symmetric is not satisfied, and transitive is also not satisfied. Hence this is not an equivalent relation. Fine, did you all understand this? We just saw transitive not satisfied, reflexive not satisfied, symmetric is also not satisfied, so it is not an equivalent relation. So let's look into one more example. This is for 3 marks. They asked this question for 3 marks. It's a very, very important question. Now I'll just have 5, 6. A set has been given with A is equal to 1, 2, 3, 4, 5, 6. And what is the relation? I'll just define a relation x comma y. Y is divisible by x. First you need to understand what is this divisible by x. For example, I'll just write 4. Is 4 divisible by 2? Yes, 4 is divisible by 2. I'll just go with 3. And 6. Is 6 divisible by 3? Yes, 6 is divisible by 3. So now I have to check whether it is symmetric, reflexive and transitive. For this, this is actually the given content. This is a question, it's a very important question. This is a given question I have now. Now I'll just go with the reflexive. As what is the statement? Always go for the normal mantra. That is x comma x belongs to R. From where is this x coming from? X belongs to the main set A. Let's check. What does it say? Y is divisible by x is the given statement. Like x is divisible by x? Yes. That is a number is divisible by itself. X is divisible by x, which implies that x is divisible by x. This condition is satisfied. Example, if I just take an example, 1 is divisible by 1. A number is divisible by itself. So 1 is divisible by 1. Hence what can we say? Where is this 1 coming from? 1 belongs to the main set A. Be very clear for all. 1 belongs to the main set A. Hence R is reflexive. R is reflexive on what? R is reflexive on the main set A. On A. R is reflexive on A. Now, the next thing is symmetric. Do we have any symmetric condition? Let's see. what does the symmetric definition say, the normal mantra? As x comma y belongs to R, as x comma y belongs to R must imply y comma z, y comma x belongs to R. A student going from college to house, house to college. So now what does this say? That is, or you can just say that is, y is divisible by x. Y is divisible by x does not imply x is divisible by y. For example, here I'll just go with 2 comma 4. 2 comma 4. What does it say? 4 is divisible by 2. 4 by 2. But can I say that 2 by 4 is 2 divisible by 4? It's impossible. It's a rare case. So that is why here this condition is not satisfied. We can say as x comma y belongs to R does not imply y comma x belongs to R. That is, y is divisible by x does not imply x is divisible by y. You can just take an example from this. Fine. 2 comma 4. 2 comma 4, 4 is divisible by 2, but 2 is not divisible by 4. Then what we can say, hence R is not reflexive, R is not symmetric. R is not symmetric on the set A. Now the next thing is, after the symmetric we have transitive. Transitive is like as x comma y belongs to R and y comma z belongs to R must imply x comma z belongs to R. This must imply x comma z belongs to R. Now let's see this. As x comma y belongs to R, what does it say? So now I'll just make use of one of the property which we actually go for. Now y is divisible by x. When y is divisible by x, after once you divide, that is 4 by 2, will you be getting a constant here? Yes. Can I just take that constant as k? Fine. So y is equal to xk. Can I use the same form to make you people understand here? Now x comma y, what does this say? Y is divisible by x, that is y by x is equal to what? I'll just go with k1. And what do you have here? You have y comma z, that is z is divisible by y. Z by y is equal to k2. Now y is equal to x k1, z is equal to k2y. What is that you can actually draw from this? I have the value of y here. Can I substitute this value of y in place of this? Yes, that is z is equal to k2 k1 x. This whole thing I am just considering it as a constant. So z is equal to k3x. What does this say? Look at this. What does this say? Can I just bring back this x to the denominator? That is z by x. Z by x. What does this say? Z is divisible by x. This is what we were supposed to prove, right? When z is divisible by x, when z is divisible by x, this obviously say that x comma z belongs to R. When z is divisible by x, you can easily write x comma z belongs to R. When x comma z belongs to R, what is the condition that we had taken? X comma y belongs to R. Y comma z belongs to R. this must imply x comma z belongs to R. Are we not getting this? X comma z belongs to R? Yes. So can we say that it's a transitive relation? Yes, it's a transitive relation. So R is reflexive and transitive but not symmetric. On what set? On the set A. You can just quote an example for this. In an examination, if you want to make your paper very perfect, just quote with an example as well. That will definitely impress the person who is evaluating your paper. Fine. So this is also one of the important questions for the NCERT board. So with this, today I would like to conclude this, and we shall come out with a few more problems in the next class, and I hope you all enjoyed the class. Thank you so much. Meet you all in the next class. Bye.